Today, let's learn how to create a Strapinski triangle, a famous fractal named after the Polish mathematician Wacław Strapinski, who described it in 1915. This is a great example of a self-repeating pattern. We can create it using a simple iterative process. For this exercise, you will need a blank piece of paper, a compass, a straight edge, and colored pencils. Let's start by drawing a large equilateral triangle. To construct an equilateral triangle, use a straight edge to draw a line. Set your compass to the length of the line. Draw an arc from one end of the line above the line past the center point of the line. Set the point of your compass on either end of the line. Draw an arc up from the other end of the line until it intersects the first arc drawn. Use a straight edge to draw lines from the ends of the line to the intersection point in the arcs. Then lastly, erase your construction lines or your arcs to clean up the drawing. This will serve as the initial shape from which the Strapinski triangle will be developed. Let's lightly label the vertices of this triangle A, B, and C. Labels will be erased later on. Next, find and mark the midpoint of each side of the triangle. Let's lightly label these as points D, E, and F. Where D is the midpoint between AB, E is the midpoint between BC, and F is the midpoint between C and A. Using the midpoints of D, E, and F, use a straight edge to draw lines connecting each pair of points. So from D to F, from F to E, and from D to E. Now, you can see that we have formed a smaller equilateral triangle in the center of the original triangle. The points D, E, F have become the vertices of this new triangle. Color in the interior of the smaller triangle you just drew to indicate that it is removed from the fractal pattern. This removal creates a shape with a triangular hole in the middle. Now apply the same process to each of the three smaller triangles that now form the perimeter of your shape, namely the triangles ADF, BDE, and triangle CEF. In each of these triangles, find the midpoints of the sides, connect these midpoints to form smaller triangles, and remove the inner triangle. So, if I have midpoint, 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 I will then draw my line segments in each of these to create smaller triangles. And we need them to be okay. Now we have our smaller triangles. Continue with repeating step 5 for each new smaller triangle generated in the previous iteration. So remember, after we create the triangles, we need to then go color them in. With each iteration, the number of triangles increases exponentially, and the complexity of the Strapinski triangle grows. As you iterate more times, you see the characteristic patterns of the Strapinski triangle emerge more clearly. The fractal will have multiple levels of increasingly smaller triangles, each iteration adding depth and complexity to the fractal. This process illustrates the concept of recursion and self-similarity, key aspects of fractals. The Strapinski triangle, with its simple but elegant structure, showcases how a simple geometric procedure can generate infinitely complex designs. This fractal is not only important in mathematical theory, but also has practical applications in areas like computer graphics and telecommunications.